Alright, today we're talking about Chapter 2, Section 3. And we're talking about the equations of a line. It's nice and small. Alright, so I'll go down here. Okay, we can just do alrighty, so we can put this in the front here. Alright, so slope-intercept form. Alright, so this reads, we have already learned that an equation of the form ax plus by is equal to c, where a and b are not both 0, represents a line in a rectangular coordinate system. An equation of a line written in this way is in standard form. Right? In this section, we'll learn of a new form called slope-intercept form, which is useful to determining the slope of a y-intercept of a line. Let 0b represent the y-intercept of a line. Let xy represent any other point on the line where x is not equal to 0. Then labeling the points and applying slope formula we have, and what this is getting at, right? If you want to make sense of it, you're more than welcome to. I mean, it's nothing difficult. I just don't think it's necessarily pertinent to what you're trying to do, right? You're trying to get into this class and get out of here. This is the math behind it, and the more I speak, the more I feel like I really probably should talk about this, because I mean, well, all right. So what this is saying is you know, if we abide by these parameters right here, okay, and by substituting in to our slope formula, we are able to get this equation. Y is equal to mx plus b. Right? Y is equal to mx plus b is important because it is the slope-intercept form of a line. Y is equal to mx plus b is a slope-intercept form of a line. I just said that, I know, I'm sorry. M is the slope and the point 0b is the y-intercept. Okay, so obviously we know m is the slope because we've talked about slope. And 0b is going to be the y-intercept. So whatever b is, it's going to be 0, and then whatever that number is, that will be the y-intercept. Right? So looking at this equation here, the equation y is equal to negative 4x plus 7, if we write, it's written in slope-intercept form, right? We see that the number in front of the x, negative 4, that is the slope, okay? And the number all by its lonesome over here, 7, that is the y-intercept, right? And it's, I hesitate to say this, but it's literally that simple. And of course, we'll see, you know, just how simple that might just be with this example here. Right? So this reads, given 3x plus 4y is equal to 4, write the equation of the line in slope-intercept form, then find the slope and y-intercept, okay? So in order to do this, you need to solve for y, right? That's not abundantly hard, so let's go ahead and get started. So first thing I'm going to do is I'm just going to go ahead and subtract 3x from both sides. So I've got a 4y is equal to a negative 3x plus 4. Okay, so again, all I did there was I subtracted 3x from both sides. I took it from the left side and I put it on the right side. Okay, next thing I'm going to do is I'm going to divide both sides by 4. Right, so by dividing both sides by 4, I'm going to have a y is equal to a negative 3/4 x plus 1. Right. Well, I solved for y, and now it is in slope-intercept form. Okay, how is it in slope-intercept form? Well, we solve for y, right? That's as easy as it gets. So we'll put these m for slope, and then the y-intercept is there, okay? So the slope is going to be this number right here, the number that's in front of the x. Okay, well, that's pretty easy. It's going to be negative 3/4. Okay, and the y-intercept is just this number by itself, right? So it's going to be 0, 1. And that's it. That's example 1. We solve it for y, and then we just identify what numbers go where. Okay. All right. So graphing a line. Okay. Doesn't necessarily I swear, I just looked at this. It's the tablet mode. I say that because I like having, because I know that my graphs aren't going to be nearly as gorgeous as, you know, a nice computer generated graph. So that's why I said that. But, you know, we're gonna make do with what we have here. Alrighty, so y is equal to negative 3/4 x plus 1. Okay, so what this means, it looks like, well, let's do plus 1. Let's actually go to 5. That'd be better. Okay. So looking at this equation, we see that we have m is equal to a negative 3/4. Okay, so let's try to write this m a little bit better and this 3 a little bit better. Okay, and then my y-intercept is going to be 0, 1. Okay, all right, so in order to graph this equation, excuse me, what we're going to do is we're going to start at do y-intercept. Okay, the y-intercept is at 0, 1. So what I'm going to do is I'm going to go up here and I'm just going to plug a point in there. Okay, all right. So after this, now we're going to be using the slope. So you plug in your y-intercept. All right, where are you on the y-axis? And then you're going to go with your slope. Okay. Now, last lecture, I very briefly just said, right, I remember just saying, you know, or it's fall over run. Okay, so let's talk about this for a moment. Okay, so this slope is negative 3/4. We know that slope is rise over run, correct? It's rise over run if it is a positive slope. Okay, this is a negative slope. So what you're going to be doing is instead of rising, you're going to be falling. And I know that might be kind of confusing, but you're basically just doing an opposite of one thing. Okay, so if it's positive, it's rise of run, it's true. Okay, that's the slope. I mean, and honestly, it still is a true thing, rise over run. It's just you're rising negative 3 units, which, you know, that's just the way it is. So what we're going to do is we're going to now say that no, we're not rising 3, we're going to be falling 3. Okay. So very briefly, what we're going to do is we're going to do down 3, 1, 2, 3, okay, and then we're going to be running 4 units. So we're going to be running 4 units, 1, 2, 3, 4. So the other point is going to be right here, and then all we do is simply connect the dots. Well, that's actually not terrible. Okay, so that's how we graph a line using slope-intercept, and I'm sorry, using the slope and y-intercept. Okay. All you do is find your y-intercept, and then from there use your slope. If it's a positive slope, do the rise over run. If it's a negative slope, fall. Right, fall and run. Okay. This is going to. I'm just snipping this whole thing because, yes, it's useful, but it really just kind of gives you an idea of the algebra behind it, right? You might have one problem like this in your homework. So I'm just going to snip all of it because there's really not much computation behind it. All right, so the example reads, use slope-intercept form to find an equation of the line with slope negative 3 and passing through the point 1, negative 4. Okay, so we start off with our slope-intercept form. Okay, we are given that the slope is negative 3 and we're passing through the point 1, negative 4. Okay, so we are given the slope, so we plug in negative 3 for m, and we see that here. Okay, and we're also given the point 1, negative 4. So 1 is the x value and negative 4 is the y value. And that's what you plug in down here. Okay, so we see we have the y, the slope, and the x. And then when you have all those, you plug it in and you solve for the unknown, which and the only unknown here will be b. So we solve for b. Right, negative 1 is equal to b, and then from there we have our slope-intercept form. Okay, now again, I'm not positive why in the world this is even thrown in there. I guess again just to kind of show you the algebra behind it. But in terms of our homework, I don't. This isn't the crux of our of this section. But I will say that I'm sure the publishers are smarter than I am about this, and it needs to be in here. But you know, it is what it is. All right, so we're not going to talk about the calculator. All right, now this is a big deal, and normally in other textbooks, I feel like this goes first, and I'll tell you why. Obviously, right? That's my job. Because I think of the point slope formula as more of the equation generator. Okay, what I mean by that is these point slopes that we are getting. Okay, in the first couple examples, again, the point slope formula, right? Y is equal to mx plus b. These point slopes. I'm sorry, I was reading it. The slope-intercept formulas that we've seen so far. This equation, that's slope-intercept. You know, all these equations up to now have been slope-intercept. I feel like the point slope should have went first because, like I said, it's the equation generator. And we'll see what I mean by that whenever we get to the examples here. But we see we have the point slope formula is given by the formula y minus y1 is equal to m times x minus x1. Okay, where m is the slope of a line and x1, y1 is a known point in the line. Right. Again, unfortunately, this is another equation that you have to memorize. So far, I believe we've got the slope formula, the slope-intercept formula, and now we have the point slope formula. These have to be memorized. And before I go too far as to why I think it's the equation generator, let's actually start with the example because I'm pretty sure, yes, this is why I think it's more of the equation generator. Okay, I wonder if we can put this on the same page. Yeah, we have plenty of space. Okay. Alrighty, so this example reads, use the point slope formula to find an equation of the line having a slope of -3 and passing through the point 1, -4. Okay, so what we're going to do is we're going to use the point slope formula. So let's go ahead and rewrite the point slope formula. Okay. All right. So by definition down here, this reads that m is the slope and x1, y1 is a known point of a line. Okay. So what this means is we can essentially just kind of, you know, bring this y on down, bring this x on down, and then we substitute as needed. Okay, so the substitutions here will be it says y minus y1. Well, the y is a -4, so it's going to be a y minus a -4. That's going to be equal to the slope. We said our slope was -3. Okay, and then x minus, well, x1 is a 1, right? So we're going to say x minus 1. Okay. So all we did was just kind of plug in what we know, right? And obviously that's all you can do. You just plug in what you know. This last sentence here, though, is write the answer in slope-intercept form. Okay. So when you write this answer in slope-intercept form, well, what we need to do is just do the algebra here, right? Let's just clean this problem up, right? Y minus a -4, that's going to be y plus 4. That's going to be equal to, looks like a -3 x, and looks like a plus 3, right? Because we distribute there, right? And then we solve this for y. We've got y. Let's fix that y a little bit. We've got y is equal to negative 3x, and we're going to subtract 4 from both sides, so it's going to be negative 3x minus 1, right? Because 3 minus 4 is negative 1. Okay, and there we have it. We have written, as requested, write the answer in slope-intercept form. We have taken this equation from the point-slope form up here, and we've got it all the way down to the slope-intercept form. So what I mean by that, the point-slope form is the equation generator, is because given all the information that you will have, you can generate that equation. You generate the slope-intercept form of an equation. Okay. Well, that's it. That's all I got. That's my take on it. Why I call it the equation generator. 3x, negative 3x minus 1. Okay, good. I'm just always worried that I'm just do something wrong, you know? All right, so let's give another example of why I call it the equation generator. Excuse me. Okay, so this reads, find an equation of a line passing through the points 5, negative 1, and 3, 1. Write the answer in slope-intercept form. Before we do that, let's do this real quick. Boom, boom. 5, negative 1. Looks like 5, negative 1, and 3, 1. Okay, so this green line here. What this is asking us to do is find the equation of that green line. Okay, looking at it, obviously you're like, I don't know. I don't know the equation of that green line, and that's fine. You're not supposed to. Okay, well, not off the top of your head, anyways. What you have to do is use the equation generator, as I said, which is the point slope, and then when you plug everything in and solve for y, you'll get the slope intercept, which will be the which would be how you can, which would be the equation of that graph. Okay, so let's go ahead and do that. And before we begin, let's go ahead and write the point slope formula. So we've got the formula is y minus y1 is equal to mx minus x1. Okay, so we see we have 2 points here, and honestly, before we start that, we need to do this. Got ahead of myself. And then let's put the points up over here. Okay, here we go. We've got the slope y2 minus y1 over x2 minus x1. Okay, so we need to figure out what the slope of this equation is. So if we did the arithmetic here, y2 minus y1, that's going to be 1 minus a negative 1 over 3 minus 5. Okay, well, 1 minus negative 1, same thing saying 1 plus 1. That's 2. And 3 minus 5 is a negative 2. So my slope is a negative 1. Okay, so this is my slope. Let's see, maybe we can, I wonder if I can move this over. Oh, I took the 2 off with it. Let's try this again. Oh, no. There we go. Okay, so my slope is a negative 1. So in my point slope form here, this m is going to be a negative 1. So let's go ahead and do the thing we did earlier where we just kind of said, okay, we're going to drop it down. So let's first, we said we're going to drop this y down, right? We said we did that. We said we're going to drop this x down. Perfect. Okay, and then we're going to have a negative 1 for an m. So negative 1. All right, so now I need to figure out what this y1 and what this x1 is, okay? Well, x1, the y1 and x1 represent a point, Okay, well in this particular equation we've got 2 points. Which one do I use? Well, the answer is always going to be the easiest one, okay? Well, they both work, and I'll demonstrate how they both work here in a moment. But I would choose the ones without negative numbers, right? Now, you won't always have that option, but if you do have that option, roll with it. So I'm going to use the one that is not negative, or without negative numbers, so 3, 1. So it has a 1 for a y, so we have y minus 1, and then a 3 for an x, so x minus 3. We solve this, we've got y minus 1 is equal to a negative x plus 3. We add 1 to both sides, we have y is equal to a negative x plus 4. Okay, so y is equal to negative x plus 4 is my equation, or yes, my answer in slope-intercept form. Boom. Let's put it green actually. Y is equal to negative x plus 4. Okay, so remember that because I'm going to erase it. All right, but negative x plus 4. So in this, for that route, I chose this point. All right, what I'm going to do now is show that I can use this point. Okay, so negative x plus 4. So let's erase this. And we'll erase this and this. Okay. All right, so now we're going to use the front point here. All right, the y value is a negative 1, so it's going to be a y minus a negative 1. My x value is going to be a 5, so it's going to be y or x minus 5. Okay. We do the arithmetic here. We've got y minus a negative 1, so it's going to be y plus 1 is equal to negative x plus 5. Right, negative 1 times negative 5 is a positive 5. And then if I subtract 1 from both sides, we've got y is equal to a negative x plus 4. The exact same thing. Okay, so it doesn't matter which point you use in the point slope formula, just make sure that you use it correctly. Okay, but like I said, for me, I mean, there's nothing wrong with saying, you know, minus a negative 1. There's nothing wrong with that. It's just for me, I would much rather deal with, you know, just one negative, right? y minus 1 as opposed to y minus a negative 1. But it doesn't really matter which you use. Okay. I hesitate to say this because I will say this, you know, quite often. Well, maybe not in this class. I don't know. But this, to me, what we're about to do now is the fun part of math, where it's not mindless computation. Now, is there computation? Yes, there's going to be computation, but it's not going to be mindless computation. Okay. Instead, what we're going to do is we're going to have to use our brain and try to figure something out here. Okay. So what do I mean by that? Well, example 8 reads, find an equation of a line passing through the point 4, 3 and perpendicular to the line 2x plus 3y is equal to 3. Write the answer in slope-intercept form. Okay, so let's unpack this. We want to find an equation that passes through this point. Okay, so let's go ahead and kind of give a, well, maybe I can, okay, it doesn't have it there. Okay, so trying to figure out the best way to go about this. How about this? Let's try this. All right. All right. So Desmos. Desmos is a good tool to use here because it's just a graphing calculator. It's an online graphing calculator. Okay. So 2x plus 3y is equal to 3. 2x plus 3y is equal to 3. Okay, so that's my line. We're trying to figure out a way to make it go through the point 4,3. Okay. All right. So this is my line right here, the line given to us, and this particular problem wants us to find a line that's perpendicular to this line here. Okay. So what we're trying to do is trying to figure out a line that goes like this, that goes through this blue dot like this, straight on through, and just make a perfect X there. Okay. So that's our task. So how do we begin doing this task? All right. So let's go back to tablet mode. It's probably really loud because the internal microphone. But like I said earlier, I forgot my headset, so hopefully I won't forget it anymore. Anyways, let's begin. So what we need to do now is we need to figure out what the slope of that line was, right? So the line was 2x plus 3y is equal to 3. Right? So we need to figure out the slope of that line. Okay. Well, how do we figure out the slope? Well, let's just go ahead and put it in slope-intercept form. Okay. So slope-intercept form, we're gonna isolate the y. So we're gonna have a 3y is equal to a negative 2x plus 3, and then we're gonna divide both sides by 3. So we're gonna have y is equal to a negative 2/3 x plus 1. Okay. All right. So from this, we can see that we have a slope of negative 2/3. Okay. Well, we're trying to find a line that's perpendicular. Okay. So in order for the line to be perpendicular, it must be the negative reciprocal. So therefore, the slope that we're looking for is going to be this fraction flipped. So instead of 2/3, it's going to be 3/2. Instead of a negative, it's going to be positive. Okay. So my slope is going to be 3/2. Right. So there's my slope, and we're wanting to go through this point 4,3. Okay. Well, you're in luck. The very formula is called point slope, right? What do you need for the point slope formula? Well, you need a point and you need a slope. We are in luck here. Okay. So let's go ahead and write that equation real fast. So y minus y1 is equal to mx minus x1. Okay. Well, again, the y comes down, and then y minus y1. Well, y1 is equal to 3, so y minus 3 is equal to, now the slope I need is 3/2, right? So 3/2 is my slope, and then x minus, what's my x value? My x value is 4. So let's clean this up. So we have a y minus 3 is equal to 3/2 x minus, well, 3/2 times 4, that's going to be 6. Okay, and then we're going to, y minus 3, we're going to add 3 to both sides. So we're going to have y is equal to 3/2 x minus 3, right? Because I add 3 to both sides. So the equation of a line that passes through this point 4,3, that is also that is also perpendicular to this line right here, the 2x plus 0 is equal to 3. That equation is here. Okay, and let's verify real quick. Ooh, fingers crossed. 3/2 x minus 3. So 3/2 x minus 3. Y is equal to 3/2 x minus 3. Boom. All right. We see that we are indeed perpendicular, and we're going through this point right here. Okay, we're going through the point that was given to us. So there's the point. We see the point here. Go with the minus 3. We go right through it. So that is indeed the equation of the line that satisfies that. Okay. Actually, before I go back in the tablet mode, let's see if I need that calculator again for example 9. This is actually pretty good right here. We're gonna snip this all by its lonesome. All right, this I wouldn't necessarily say it's a cheat sheet, but it's definitely something that you could use. Okay, well, this is pretty darn easy example, so we're just going to go ahead and snip this all by its lonesome. Okay. All right, so this reads, find an equation of a line passing through the point -4, +1, and it's perpendicular to the x-axis. Okay, well, if it's going to be perpendicular to the x-axis, we saw in the previous section that any line perpendicular to the x-axis is vertical. Right? That should be obvious, right? All right. Well, recall that all vertical lines can be written in the form x equals k, where k is the constant. A quick sketch can help find the value of the constant. So again, we're trying to find a line that passes through the point -4, +1, which is this point right here, and it's perpendicular to the x-axis, and this is the x-axis right here, right? And if we want to make it perpendicular, well, like I said, all we need, the x-axis is horizontal. In order to make it perpendicular, we just need to make it vertical. So therefore, that's just going to be the equation x equal -4, and that's it. Hopefully that's not too hand-wavy for you. But anyways, that concludes Chapter 2, Section 3, I believe.